Hi, hi friends, welcome to our channel. Today we are going to continue our topic class 11 chemistry atomic structure chapter 1. Okay. And before class we discussed up to stopping potential. Okay. Now we discuss a new topic, spectrum. Yeah, spectrum. First of all, what is meant by a spectrum? Okay, a spectrum is a orderly arrangement of wavelengths. That is called a spectrum. Means when we take a source of light, this is a source of light, and when we eject the light from the source, and the source is eject the light, and this light is passed through a prism, and when this white light passes through a prism, it refracts inside the prism and coming to outside, it disperses into various colors that we call as Vijaya. Okay. Okay. When we take a source of light and we eject the light from the source and make the light to pass through a prism, and that light is dispersed, and the dispersed light is obtained in a screen. Okay. And this is dispersion. Okay. This is dispersion. And the photograph of the light, dispersal light is obtained in a screen, right? This is spectrum. This is spectrum, and this dispersion means emitting of light. This is called dispersion, and dispersed light is obtained in a screen. This is called a spectrum. Okay. And this screen we usually call as spectroscope or spectrometer. Okay, spectroscope or spectrometer. The screen అంటే ఆ డిస్పర్స్ లైట్ అనేది మన స్క్రీన్ మీద ఫోటోగ్రాఫ్ అనేది అప్డేట్ అవుతుంది కదా, ఆ స్క్రీన్ని మామూలుగా మనం స్పెక్ట్రోస్కోప్ అయినా స్పెక్ట్రోమీటర్ అయినా అని పిలుస్తాం. ఓకే. Now see, the dispersed light having less bending, they have more wavelength, less bending of light, means less deviation of light, less wavelength, more bending. See, at the top we obtain red color, and the down we obtain violet color, which means red color having more wavelength and violet color having less wavelength. Okay. And there are so many types of spectra. Spectra is a plural form of spectrum. See types of spectra. The first is spectrum, emission spectrum, absorption spectrum. The spectrum is divided into emission spectrum and absorption spectrum, and emission spectrum is further divided into continuous spectrum and discontinuous spectrum. Okay. The emission spectrum is further divided into continuous spectrum and discontinuous spectrum. Discontinuous spectrum further divided into line spectrum and band spectrum. Okay. Line spectrum and band spectrum. Okay. Spectrum is divided into emission spectrum and absorption spectrum. Emission spectrum is divided into line continuous spectrum and discontinuous spectrum. Discontinuous spectrum is further divided into line spectrum and band spectrum. Now see, the example for continuous spectrum is rainbow. So why we call emission spectrum as a continuous spectrum? Because it having the example of dispersion of light. Usually emission spectrum, most of the emission spectrum is discontinuous. Why it is discontinuous? We will talk in the further topic. It is continuous spectrum because Emission spectrum, dispersion is nothing but emission of the various colors of light from white light. And the best example for the continuous spectrum is rainbow. Okay. So rainbow, how a rainbow looks, we have different colors in rainbow. So we have different colors, which are colors. It is continuous spectrum because it does not have any boundaries between the colors. See, it does not have any boundaries. All colors are looks like they are merged. Okay, they looks like that they are merged, but they do not have certain boundaries. Means up to this color, up to violet we have one boundary, up to red we have one boundary. It is not like that. Okay, all colors look like a merged. There are no boundaries between the colors. So it is called a continuous spectrum. Best example for continuous spectrum is rainbow. Okay. Best example for discontinuous spectrum, the chapter name only, atom. Okay, all atoms are discontinuous. All atomic spectra is discontinuous. So they have boundaries. Means they have boundaries. They have lines between them, or they have bands. Bands means nothing but molecular spectra. They have a bundle of lines, a bunch of lines. That is, we will discuss later. Discontinuous spectrum, they have boundaries between colors. You will observe in the Google this image of discontinuous. You will understand very clearly. Okay, they have boundaries. This is one color. This is one color. This is one color. This is one color. Like that, they have some orderly boundaries between the colors. So, atomic spectra is discontinuous. Very important point. All atomic spectra are discontinuous spectrum. Okay. Now see, first of all, the first spectrum, absorption spectrum. See, absorption spectrum. Now what is meant by absorption spectrum? See, when we take a source of light, when we emit the light and pass the source of light through a vapor or through any substance. So I taken a substance called vapor. I taken a vapor substance and pass this substance through vapor and obtain this in a prism, and again pass it through in between a prism. When we incident or we eject the white light from a source of light in vapor in any substance, this travels, and here we take a prism. Spectrum of lines is observed, but not 7 colors is not observed. Only 3 or 4 colors is observed. Why? Because only some colors are observed in the spectroscope. This is a spectroscope. Why only some colors? Because some colors are observed by this vapor, by this substance. Okay, that's why only a few colors observed on the spectroscope. Why it is observed some colors? Because in vapor we know atoms are present. Any substance we have atom. Vapor is a matter. So it has atoms, right? When the light is fall on the vapor atoms, the energy is absorbed. Means the electron jump from lower orbit to higher orbit. According to Bohr's theory, when the electron jump from lower orbit to higher orbit, the energy is absorbed. So this is called as absorption. The energy is absorbed, and this energy, the electron excite, and energy is absorbed. And how much energy required? అంటే ఇప్పుడు ప్రతి లైట్కు వేవ్ లెంత్ ఉంటుంది కదా, ఈ ఎలక్ట్రాన్ జంప్ కావడానికి కావాల్సిన ఎనర్జీ ఇంకా వేవ్ ఆ ఎనర్జీతో కంపారబుల్ అయ్యే వేవ్ లెంత్ కలిగిన లైట్ని ఇది వేపర్ అనేది అబ్జర్వ్ చేసుకుంటుంది. వేపర్ విల్ అబ్జర్వ్ ద కంపారబుల్ వేవ్ లెంత్ లైట్ ద ఎనర్జీ రిక్వైర్డ్ ఫర్ ఎలక్ట్రాన్ టు జంప్ ఫ్రమ్ లోయర్ ఆర్బిట్ టు హైయర్ ఆర్బిట్. Okay, that colors is observed by vapor and remaining colors is obtained in spectroscope. Now how the spectrum look like? See we have with GR colors, right? Let us take for example I color is observed, G color is observed, and O color is observed. Okay. Now how the spectrums look like? See, the spectrum having dark lines on the bright background. Okay, means what are these? See, for example, let us take in the letters, in the place of letters having bright background, and the lines are the dark lines. What are these lines? Which colors observed? Indigo, green, and orange is observed, right? That colors looks like dark lines on the bright background of remaining colors. Okay, this is how the spectrums look like. You will observe the image in the Google, you will definitely understand the spectrum. Okay. See, this is how the spectrums look like. Okay, in the absorption spectrum look like. Okay, the absorption spectrum is discontinuous spectrum, very important. It is always discontinuous spectrum. Why it is always discontinuous? Because it has dark lines on the bright background, means it has some boundaries, means it has some boundaries, like the dark lines are the boundaries on the bright background. Okay, this is absorption spectrum. Okay, this is about absorption spectrum. How absorption spectrum is formed? Due to the excitation of electrons. Okay, due to the excitation of electrons it is formed, and due to the absorption of energy, it contains absorption of energy. Yeah, when it absorbs energy required, and it also absorbs the colors required comparable to the energy. Okay, that's why some colors appears as a bright dark lines on the bright background. Spectrum look like. Okay, now let us see emission spectrum. Emission spectrum. Okay, see, same example, same as it is like absorption spectrum only, but one process in that is different. And the chinna change ఉంటుంది process లో తప్ప మీద వేపర్ తీసుకుంటాం అలాగే సేమ్ అంతా సేమ్ ప్రాసెస్. See, this is vapor, right? This is vapor. How emission spectrum is formed? See, when the electron jump from lower to higher, energy is absorbed, but it has lost the stability. It has less stability. How it attains again stability? When that electron is again jump from higher to lower, then stability is gained. It gains stability. Before that, while in the higher energy orbit, it has less stability. It comes lower orbit, energy is emitted. The energy is emitted and it attains stability. So to attain stability, what happens? The electrons again jump from higher orbit to lower orbit. Okay, this is also called de-excitation of electrons. Okay, de-excitation of electrons. And the emitted energy is in the form of radiation. It is not in the form of any dispersion of colors like that. It is in the form of radiation. Okay, in that line spectrum is the de-excitation and de-excitation, but band spectrum, what happens is, the band spectrum is formed due to the radiation. Okay, so that is one more topic I will explain. So in the emission spectrum, the emitted energy, this is in the form of radiations. The emitted energy is in the form of radiations, and this radiation will be observed in the spectroscope. And how the spectrums look like? bright lights on the dark background. Okay, here we have to take the dark background here. In the spectroscope, the spectroscope is taken as a dark background and the bright light will appear. Guess what? The bright light, the bright lines in the dark background is nothing but which colors are observed by the vapor absorption spectrum. That colors look like bright lines on the dark background. In the previous, indigo is observed in the Vibgea colors, previous absorption, indigo is observed, and also green is observed, orange is observed. That colors only looks bright lines on the dark background. Okay, bright lines. This is dark background. This is bright lines, and this is I, G. So the VBYR is the dark background, and the IGO is the bright lines observed on the dark background. Okay, this is how the emission spectrum look like. Yeah, line spectrum. See, line spectrum is also example of discontinuous spectrum. So it is example of emission spectrum also, except the dispersion of light, it is continuous, and the remaining all is discontinuous. And that discontinuous, one more spectrum is line spectrum. See, line spectrum is assigned. Line spectrum is also called as atomic spectrum. Why? Because it is only, we see line spectrum in only atoms. In only atoms we see the line spectrum. So it is called atomic spectrum also. Atomic spectrum, we discussed that it is discontinuous spectrum and it has a single lines, single boundaries between the colors. This is line spectrum. It is due to excitation and de-excitation of electrons. Means the electrons move for lower to higher excitation and higher to lower. This is excitation. It is due to excitation of electrons and de-excitation of electrons. Okay. So this is nothing but line spectrum. This is only the line spectrum. Okay. They are having thin distinct lines. Okay, they are having a thin distinct lines in the spectrum. This is line spectrum. Okay, now see similarly band spectrum also. Band spectrum. See how band spectrums look like. In band spectrum, the bands are closely packed. These are called bands. Means the lines which are closely packed, called band. Okay. How it is formed? Due to, it is also called molecular spectrum. Means it is only observed in molecules. It is not observed in atoms. Okay. It is also called molecular spectrum, and it is due to rotation and vibration of atoms in the molecules. It is due to rotation and vibration of atoms in the molecules, the band spectrum is formed. Okay, this is how it looks like. And this is about line spectrum. These both are examples of discontinuous spectrum because they are having the boundaries here, a densely packed bands having between the colors. This is called band spectrum. Okay, it is a molecular spectrum. And it is formed due to rotation and vibration. In the molecules, we know atoms are present. And due to the rotation and vibration of atoms in the molecules, band spectrum occurs. Yeah. This is about types of spectra. And one more important point is, in sodium atom, sodium spectrum, okay, sodium atom, in sodium spectrum, in sodium spectrum, containing two yellow lines. Sodium spectrum is containing two yellow lines. They are having two different wavelengths, D1, D2. Let us take these two yellow lines are D1, D2. D1 having wavelength of 5890 angstroms and D2 having 5896 angstrom wavelength. convert angstrom into lambda form, you know that 1 to 12,400 by lambda. Okay, this is one important small note point. Okay, helpful for the objective ones. Okay, this is about types of spectrum. Hope you understand this class, enjoyed this class. Thanks for watching. Let us meet in the next video. Thank you.